For generations, astronomers have looked toward a mysterious light burning in the shoulder of Orion and wondered whether they were watching a star, or a countdown. High in the winter sky glows Betelgeuse, a crimson giant unlike almost anything visible to the naked eye. Its reddish light does not shine with the calm steadiness of ordinary stars. It flickers. It pulses. It seems to breathe, as if something deep beneath its surface is shifting in slow cosmic convulsions. There is something unsettling about it. Something ancient. Unstable. Almost alive. But Betelgeuse is far more than a bright point in the sky. It is a colossal red supergiant, a dying titan so enormous that if placed at the center of our solar system, its outer layers could stretch beyond the orbit of Jupiter. Mercury would vanish inside it. Venus would disappear. Earth would be gone. Even imagining its scale pushes the mind toward absurdity. Yet what makes this star extraordinary is not just its size, it is its behavior. This is not a quiet giant nearing a peaceful end. It behaves like a star in turmoil. For decades, astronomers have watched its brightness fluctuate in strange rhythms. Some follow expected patterns. Others refuse to fit any prediction. And then, in late 2019, something happened that stunned the world. Betelgeuse began to fade. Not slightly, dramatically. Its brightness dropped to nearly 1/3 of normal. Around the globe, telescopes turned toward Orion. Scientists and the public asked the same question: was this it? Was one of the sky's greatest stars about to die? Because if a red supergiant only about 700 light-years away were to explode, humanity would witness one of the most extraordinary events in history. For weeks, perhaps months, it might rival the moon in brightness. Visible in daylight. Casting shadows at night. A second brilliant object hanging over Earth. The thought was thrilling, and deeply unnerving. Because stars like Betelgeuse do not simply fade forever. Eventually, they explode. For a brief moment, it felt as if the universe was holding its breath. Were we watching the beginning of a supernova in real time? But the explosion never came. Instead, the star recovered. It brightened again, and left behind a deeper mystery. What looked like a death warning became something stranger. A star on the edge of catastrophe, yet refusing to fall. Scientists searched for answers. Some proposed vast clouds of dust had formed, temporarily blocking its light. Others suggested massive pulsations had lifted material from its surface, cooling regions of the star. But when infrared observations pierced through the dust, the mystery deepened. Betelgeuse was not quietly aging. It was violently active. Its surface is not smooth, it resembles a boiling ocean of plasma. Massive convection cells churn across it like bubbles in a pot of water, except each bubble may be larger than Earth's orbit. Hot material rises, cools, and sinks again in enormous cycles. Bright regions flare unpredictably. Dark zones drift like colossal shadows. The star does not look stable. It looks restless. And beyond that surface lies something even stranger. Surrounding Betelgeuse are vast shells of gas and dust, evidence of violent eruptions powerful enough to eject parts of the star itself. Some may be relics of events centuries old. Many astronomers now believe one of these eruptions caused the Great Dimming. A massive plume may have blasted outward, cooled into dust, and drifted into our line of sight. For a time, the star dimmed itself. But this raises a deeper question. Are these eruptions warning signs? Because they suggest that the final stages of massive stars may not be calm and predictable, but chaotic. Violent. Unstable. Maybe a star's death does not begin with a single explosion. Maybe it begins long before, with turbulence we are only starting to understand. And that uncertainty is what makes Betelgeuse so fascinating. Because it has become more than a star. It is a laboratory for testing the limits of stellar physics. And beyond its instability lies an even greater story. Because dying stars do not merely end, they create. When a supernova erupts, it sends shockwaves through space, compressing gas and dust. Over time, those regions may collapse into new stars, new planets, perhaps even life. Which means Betelgeuse is not only approaching death. It may already be helping seed creation. This is the paradox of the cosmos. Stars die so others can be born. And when Betelgeuse finally explodes, and someday it will scatter elements essential to life: carbon, oxygen, iron. Everything in your body was forged in stars that died long before the sun existed. You are made of stellar debris. And Betelgeuse is preparing to continue that story. But when? That remains unknown. It could happen tomorrow, or in 100,000 years. In cosmic terms, both are equally possible. Modern instruments continue to reveal new clues: uneven structures, violent mass loss, strange asymmetries.